that when you observe or when you measure something, you are perturbing the system, you're changing the system. We can measure only collapse states. We can change space. We can change the wave function.
Yes, now get ready for a mind-expanding conversation with Professor Vaknin. Welcome, Professor Vaknin.
Thank you for having me.
Today we are having a very mysterious subject, and I'm starting our conversation. The one who observes reality, or the one who observes the act of observing reality? Who is truly consciousness?
If you are referring to quantum mechanics, where the observer has a role in creating reality, then I think we need to clarify a few things. And we need to clarify a few things because there has been a wave of new age writers and all kinds of physicists who have become mystics and all kinds of people. And they completely distorted the meaning of the observer in quantum mechanics. Mm-hmm. So what I'm going to say today would be interesting and would be mysterious, and hopefully would be mind-expanding, but it would be founded 100% on the science, on physics. So let's start with the fact that the observer in quantum mechanics does not need to have a mind, does not need to have a consciousness. Anything that registers an event is an observer in quantum mechanics. So it could be a photographic plate, mm-hmm. It could be a laptop, it could be a particle detector. So anything that registers the appearance of a particle is an observer mm-hmm. in quantum mechanics. It doesn't have to be a human being, it doesn't have to be a sentient being or a conscious being, which is not human. It doesn't have to possess intelligence, it doesn't have to possess consciousness. All this is nonsense. Has nothing to do with the science. This is point number one. However, it does raise an interesting question. This photographic plate, let's say, or this laptop, or this particle detector, that register the appearance of a particle, do they create the particle, or do they just record a created particle? So this question remains. Mm-hmm. Never mind that the photographic plate doesn't have intelligence, or the laptop is not conscious. The question still remains, what is the role of the observer? Is the observer a co-creator of reality? Or is the observer merely, as the name implies, an observer? Mm-hmm. Actually, in quantum mechanics, we don't use the word observation. We use the word measurement. Mm-hmm. Now to go back a bit, in order to answer this, in my view, fascinating question, and question that sounds a bit mystical. To answer this question, we need to go a bit back to a guy called Schrödinger. Schrödinger, as the name implies, was a German, of course, and Schrödinger came with an equation, invented an equation known as the Schrödinger equation, surprisingly. Later on in the history of quantum mechanics, the Schrödinger equation was renamed the wave equation. Mm-hmm. What is the wave equation? Again, New Age authors, rogue physicists, mystics, and religious figures, I don't know what, they confuse the wave function with reality. The wave function is not a real thing. The wave function is a table. Think of it as a table. Mm-hmm. And in this table, we list the probable locations of a particle when a measurement is affected. So think of it as a table like this. 10% that the particle will be here. 20% the particle will be here. Mm-hmm. There's a 50% chance the particle will be here, between us. And whatever is left chance that it will be behind me. Uh-huh. When I make all this list, I'm creating a wave function. Mm-hmm. Because if I connect the
possibilities, like
it's probabilities. Mm-hmm. So it's a list of probabilities of where we are likely to find a particle if we measure, mm-hmm. if we create a measurement. In other words, the wave equation, or the wave function, the wave equation is an equation. it has nothing to do with reality whatsoever. It does not designate or describe any physical entity. It does not say anything about reality. It reflects our ignorance, our imperfect information, because we have no way to determine in advance where a particle would appear. Then we are forced to make a list where it might appear. This is, of course, a good definition of ignorance. Yeah? And so, now that we understood that the wave function is essentially a probability table, a table of probabilities, and we understood that the observer doesn't have to be conscious and doesn't have to have a mind, you know, the question remains, how come the observer solves the wave function? Because we need a photographic plate or a laptop or a conscious observer, a scientist, or we need something to register the event. But when you register the event, you solve the wave function. You collapse it. You reduce it. The two terms that we use are collapse and reduction. So at that moment, when you measure, and again, it's not relevant that you have a mind or you don't have a mind or conscious, you're not conscious. At that minute that you measure, there's no debate that you eliminate all the probabilities and you remain with 100% probability of the particle that appeared. However, what you observe and register is a change in the properties of the wave function. What you're observing is an increase in probability. In other words, what you're observing is a change in a mathematical equation, not in reality, but in a mathematical equation. Still, why do we need measurement? It's a very interesting question. Like, the wave function has existed from the beginning of time. What people don't know, if they are not physicists, what they don't know is that the wave function does not only describe the particle. A part of the wave function describes the universe from its very beginning. So the Schrödinger equation starts off as a deterministic equation, which describes the evolution of the entire universe. And then it becomes probabilistic when it attempts to answer the question, where would a specific particle appear? So when we measure the particle, we solve the wave function for the totality of the universe from the beginning of time. And that raises the question, how did the universe evolve? How did it come into being when there were no observers?
Yeah.
There was no photographic plates and no conscious, when life did not begin. Even under the most optimistic estimates, most wild, crazy estimates, the conditions for life, or at least as we understand life, the earliest life could have appeared anywhere in the universe, not on Earth, was about 1 billion years after the Big Bang. What happened? Who observed the universe in these 1 billion years? Of course, if you're a religious person, you would say God observed the universe these 1 billion years, and then he created men because he was tired observing the universe for 1 billion years. He created men, and men now took over the job. Shifts. There were shifts, you know.
Yes.
There was a shift change. But if we exclude God and other such imaginary friends and creatures from the story, we still are left with the question of who observed the universe
first
into existence when there were no observers of any kind, conscious or not conscious. So I would like to suggest 3 solutions. But before I suggest my solutions, I want to make clear that the brightest minds in the history of science have coped with this question. This question is the key question since 1920. And the biggest minds, that is Albert Einstein and Niels Bohr and Max Born, you name it, and everyone has dealt with this question. Everyone. And they came up with many solutions. One solution was to say that an observer is critical. The act of measurement collapses the wave function. And if there's no measurement, there would be no collapse, and the wave function would remain in its potential state forever. until it is measured. And of course, many physicists found it very bizarre, because like one physicist asked, so the whole universe was waiting 14 billion years for me to conduct an experiment and collapse the... Because remember, the wave function describes the whole universe, not a particle, like people think. The whole universe. So the whole universe was waiting until some physicist conducted an experiment in a laboratory, and then the wave function collapsed. Instinctively, it sounds stupid. Sounds stupid. So the Copenhagen interpretation of quantum mechanics that says that measurement is a sine qua non, a precondition for collapse, is very doubtful. It sounds crazy, and so, and also is very anthropocentric. It elevates humans. Humans become gods. They create the universe. They solve the universe. You know, it's very narcissistic. So many physicists try to find alternative explanations. So, for example, we have the many worlds interpretation. Everett.
Universes can
Everett came with the idea in 1957. He came with the idea that whenever you conduct a measurement, essentially the universe splits. So when you conduct a measurement, there's one universe where the measurement did not take place, and one universe where it did take place. It's not exactly this. It's not exactly the universe. It's just something to do with what we call eigenstates. But I will not go into it right now. It's okay to think of it metaphorically as if the universe is divided. So this is one solution, because if we always have a universe where a measurement took place and a universe where it did not take place, then theoretically we could have universes where the measurement took place much earlier than when we conducted the experiment, and so the problem is solved. That's one approach. Another approach is known as top-down cosmology. It was first proposed by Hawking, Stephen Hawking. It's very similar to Everett, many worlds theory. And these two approaches together gave rise to the idea of a multiverse. Multiverse was multiplicity of universes. There, again, a misunderstanding in the public is that a multiverse is simply many universes, like balls, beautiful, colorful balls floating in the air. And that's not a multiverse. Because, for example, a universe can exist on the border, on the boundary between two other universes. Our universe, actually, according to string theory, is a boundary universe. It's not a full-fledged ball, but it's like on the border between two balls. So it's like this kind of universe. So there are many types of universe. There are M-branes, so on. I will not go into all this. So this is one approach, the many worlds, or the multiverse approach. And there are many other attempts to interpret quantum mechanics in order to get rid of this very bizarre condition that a measurement collapses the wave function even when there was no one to conduct the measurement, when the universe started. And I would like to propose a few modifications. Well, I mean, I did propose them. I originated a theory initially in astrophysics, and now it's a theory of all of physics. It's a theory of everything. And now scientists all over the world are working on it. And the lead scientist is Eitan Sachard. I need to mention his name. He deserves a lot of credit. And my theory approaches the measurement problem very differently. I will try to explain in which ways it approaches very differently. There is an underlying assumption, and I always like to challenge underlying assumptions. In all the fields where I work, economics, physics, and so on, I always challenge underlying assumptions because we always get stuck because of these assumptions. We cannot progress because we make assumptions, and then we say these assumptions are taboo, they're sacred, and we should never question these assumptions. And we get stuck. There is an assumption that the wave function, in principle, is measurable at all points. Like there is a wave function. Let's assume there is a wave function. I can measure the particle here, I can measure it here, I can measure it here, and so on and so forth. And in my work, this is not true. In my work, we as human beings and the machines we invent to measure, like photographic plates and so on and so forth, we are selective membranes, we can measure only collapse states. It's not that when we measure we collapse the state, it's that we can measure only collapse states.
Who made it collapse?
The collapse is there. That's exactly what I'm saying. I'm saying all wave functions, and definitely the universal wave function, the Schrödinger equation, collapses autonomously. It doesn't need any measurement or any observer or anything. It collapses. When we come to the scene, because of the hardware we have and the special software we have, the brain, we can measure only collapse states. Let me give you an example. So we have three mugs here. This is the wave function. You can measure this mug, or this glass. This is the wave function. Okay. So one option is to say, here I am, I'm conducting experiment, and I found out this mug. I created this mug. Before I came, this mug did not exist. I made it happen. Another option is to say, everything exists. Everything does exist. Everything is already collapsed. But my equipment, my brain, my laptops, my photographic plates, my particle, is built to detect only collapsed states. Is not built to detect this mug. Is not built to detect this glass, although they do exist. We are built to detect only collapsed states. This is an approach that solves the problem. Because if we have a selective equipment, not an equipment that can measure all possible situations, but an equipment that can measure only collapse, then of course we will constantly measure collapse. We will never measure non-collapse. We'll measure only collapse. It's a little like daltonism, color blindness. When you're colorblind, everything looks, I don't remember, blue, red, whatever. So we are colorblind. We are collapse blind. We are collapse blind. We cannot see green, and we cannot see yellow, and we cannot see blue, and we can see only
the collapse.
And so when I turn on my experiment or my measurement devices and so on and so forth, in advance I know that I will measure only a collapse.
Then your theory doesn't need an observer.
No. An observer doesn't need an observer. Yes, the universe exists without observers, of course.
Yes.
And there is this particular life form, a professor of physics is a life form, there's a particular life form that conducts measurements. And this life form is built in a way to detect only collapse. It cannot detect non-collapsed states, only collapsed states. Why is it like that? Why would we have an equipment that cannot detect other things, not collapse? Why can detect only collapse? Because collapse states are helpful for survival. When we know that non-collapsed states, which exist, non-collapsed states do exist, we know that they are very brief, very temporary. They are sometimes 1/1,000,000th of a second and so on. And collapsed states can last forever. So this mug, theoretically, is a collapsed mug. And that's why I can hold it. That's why I can drink from it. If it was a non-collapsed mug, which does exist, it would last 1/1,000,000th of a second. I would have great difficulty to drink my coffee. It would spill on my trousers and make me very nervous. So that's why I have equipment to detect only mugs, only mugs that I can drink from. The difference between collapsed states and non-collapsed states is time. Collapsed states last much longer and allow us to manipulate reality and to survive in reality. I think that if there were an organism which survived for 1/1,000,000th of a second, that organism would have an advantage, evolutionary advantage, to detect non-collapsed states and to not detect collapsed states. That organism would invent measuring device that would detect non-collapsed states, because that organism would live for 1 second or 1 millionth of a second. So non-collapsed states would be much more useful to this organism than collapsed states. You have a rare brain disorder, rare. You can see only trees. You cannot see cars, you cannot see cameramen, you cannot see any, only trees. Only. So you look outside and you say, wow, I see a tree. I created this tree because I saw it, I measured it, I observed it. But the tree was always there. It's just that you have equipment that is geared, that is built to detect only trees. So our equipment is built to detect only collapsed states. I want to go further from this and move on to the next level of so this is my first attempted contribution. The second thing and by the way, this is known as pointer states. Pointer states in quantum physics are collapsed states, and they're known as pointer states because they last a long time. We know in quantum physics that typical collapsed states last very long, whereas non-collapsed states exist, but they last fraction of a fraction of a fraction of a second. 1 trillionth of a second, and so on. So they're useless. You can do nothing with them. Normally, evolution would give us equipment to detect only collapsed states. Yes? So the second, and these are known as pointer states. So the second thing I would like to mention is observers exist not only in quantum mechanics, and this is something people forget. All of relativity theory, special relativity theory, is built on observers. Observers in special relativity theory define and change time and space. Time for an observer A is not the same as time for observer B, because, for example, observer B is moving at the speed of light. So the observers in special relativity theory actually create time and space. They don't really create them, but they measure them. By measuring them, they change time, they change space. So the act of measurement in relativity theory, special relativity theory, is same exactly like act of measurement in quantum mechanics. But in relativity theory, the act of measurement creates time and space, or changes the features, the attributes of time and space. For example, time passes much more slowly when you are an observer who is moving at the speed of light. And observers in quantum mechanics create other things, collapsed states. There is no philosophical difference between the observers in relativity and the observers in quantum mechanics. They all create something by measuring. The act of measurement started with Einstein.
Then does the measurement need someone who has conscious, or
Absolutely not.
measurements can be done by itself?
Absolutely not. For example, Einstein, when he says observer, in most cases he means a clock. He describes a
time.
clock. Yeah, a clock, a watch. So when he says an observer, he doesn't mean conscious observer. He means a clock. So he says if you have a clock on a train, and a clock on the wharf, so the clock on the train, the time of this clock would be much slower. Would be slower, because the clock on the train is moving with the train. The speed elongates the time, dilates the time. So the time of that clock would be slower than the time of the clock which is stationary. These clocks are the observers. They are the measurement. So, but we keep forgetting that measurement defines the world in all physics, not only in quantum mechanics, also in special relativity. We can definitely change the speed of a clock. We can definitely expand time, dilate it, just by moving faster.
Faster.
Example. And by measuring, while we're moving faster, by measuring time. So, because this is the case, what I did in my early work, I created a united framework for observers. generally observers. And in this framework, the observer was regenerating time and space all the time, on the fly, so that it gave rise to a collapse. So I'm trying, this is very difficult to explain. It's a complex theory.
Universe can be observing itself.
Yeah, we'll come to that in a minute. Now we're talking still about universe where there are observers who are not the universe. So in my work, time is a potential. It's a field of potentials. What the observer does, the observer realizes some of these potentials. And by realizing some of these potentials, the observer creates time and space. But this is the relativistic observer. So I had to unify the relativistic observer and the quantum mechanics observer. So what I did, I created a unified observer, which has relativistic effects and quantum mechanic effects. And the collapse is a natural outcome of selecting for specific events, for specific time and space. Now, I think it would be easier for you to understand this way. If time is a field of potentials.
And then I will ask you something. What is potential? What do you mean about potential?
The potential to become something. Okay? So if time is a field of potentials, potential to become an event. Okay? So there is a potential to become...
There are potential events.
Yes. And you have there's potential to become event 1, event 2, event 9, event million, event... So if you put all these potentials together, you have time. In my work, I'm talking. Quanon field theory, in my work. So then you have but for time to become an event, you must have collapse. So time becomes an event via collapse. The event could be an elementary particle. That's an event. The observer in my work is unified, is not only relativistic, only quantum, but is a unified observer. And the role of the observer in my Quanon field theory is to realize the potential, to convert the potential into an event. And the only way to do this is via collapse. We don't have any other mechanism. So in my work, collapse emerges naturally from relativistic equations, not from quantum mechanics. When the observer in my work changes time-space, like in relativity theory, he then creates a collapse automatically. The only way to change time-space in my work is via collapse. And in this sense, it's a unified theory of relativity and quantum mechanics together. Okay, that's more or less.
I have questions, but I will ask later about
Last
this.
point I will make, and then, of course, we can move on. Last point I will make is what is known as the observer effect. The observer effect is not my contribution. Many physicists realized that when you observe or when you measure something, you are perturbing the system. You're changing the system. So the most simple example, you have an electron, and you want to observe the electron. How would you observe the electron? You send a photon. You send a light particle, a photon, and the photon hits the electron and jumps back to your eye. So you're sending a photon. The photon bangs with the electron and comes back to your eye and brings with it information about the electron. But when you bang the electron with a photon, it moves. It moves. It may also change energy level, but normally it moves. So it changes momentum. It changes position, momentum and position. So the information the photon brings back to you is wrong. It's wrong. Because the photon changed the electron. This is known as observer effect. You cannot measure anything without changing it, without perturbing the equilibrium. When I want to measure a collapse state, what do? I must choose a photon. There's no other way. if I use a photographic plate, if I use particle detector, if I use my eyes, I am using photons. I'm sending barrage, avalanche, tsunami of photons to get information back. It's the only way we have. We don't have any other way. We can, of course, send other particles, not photons. We can send electrons. We can send, like X-ray, But we always have to send a messenger. We always have to send some messenger. We send the messenger. It could be photon, could be something else, and the messenger collects the information and comes back to you. But when this messenger, when the particle that you send collects the information, it disturbs the system. It changes it. And this change is actually the collapse. We are creating the collapse, but we are creating the collapse by bombarding the system with particles that bring information back to us, and this information is what we call collapse. This is known as the observer effect approach to quantum mechanics. And honestly, it makes a lot of sense. To me, this is the most common sense explanation of the collapse. Whenever there is a measurement, there is an exchange of particles. We send photons, we get them back. There's an exchange of particles. This exchange of particles carries energy. The energy changes the system. This change in the system is what we call collapse.
And we can just see the changed one.
And we see the change and we call it collapse.
Time can exist without an observer, one is the question, because you said that time makes the collapse when they come together. Time needs an observer. Without an observer, is there time?
Yes. In my work, at least, and actually in all of physics, time-space are not the outcome of observation or measurement, but they can be changed. They can be changed via measurement. Or a measurement can change time-space, and so it has a contribution to time-space. But time-space are a priori. Time-space is a priori. Similarly, I think the wave function is a priori. I don't think it depends on measurement. I don't think it depends on measurement at all. I think it exists and it solves itself. It collapses all the time. All the time. There is a billion collapses here, all the time. Trillion collapses here. But we don't have a measurement device. Now if I take a measurement device, I put a photographic plate, one of these collapses will be registered on the photographic plate. And I say, you see, I created the collapse. No, I did not create the collapse. I detected the collapse. Because my photographic plate can detect only collapse.
The collapsed ones.
Only. Cannot detect non-collapse, because non-collapse lasts 1/1,000,000th of a second. So we cannot detect it. And similarly, time-space is there. But in the absence of measurement and in the absence of observation, we will not have information about the variation of time-space in different regions. So for example, if we have an object in time-space that moves close to the speed of light, this object would have a different time. If we have an object with a huge mass, this mass will distort space. Space will be distorted next to the mass. But we will have no information about it, because we were not there to conduct any measurement. Measurement, on the one hand, is just information about what's happening out there, but we also have the power in special relativity. We have the power to distort time and space. We can do it ourselves. We don't need a star. We can do it on our own. Similarly, I think in quantum mechanics, everything is happening without us all the time, but we have the capacity to detect collapse, to capture it. And as we can influence time and space, we can influence the wave function by detecting a specific event, capturing it in some way. Because one thing I think that many people ignore, including physicists, when you capture a collapse, you capture a part of reality. When you have a photographic plate and suddenly you see a dot, black dot on the photographic plate, or a spiral or whatever, It's not just a painting. It is the particle. It is the particle. You capture it. So you confiscate, you take a part of the wave function. You own it now. It's yours, you know? So we do interfere with reality when we measure. Measurement is an act of interference in reality. That's why the observer effect is very important. We interfere. We are active participants in the creation of space, time, and collapse events. This is our filter, our structure, our hardware, our software.
Chooses that.
Chooses, exactly. It's a selection process. We
Then
select for time.
Time, space, and possibilities.
And collapses.
And collapses are always
there.
Around us.
Yes.
But when we see the collapsed reality,
Yeah.
we understand the time according to that.
Yes. Time, we have two possible functions. We can only measure, be passive in measurement, and then we get information about space, about time, about collapse states. We cannot measure all the wave function. That is wrong. We can measure only collapse states.
Collapsed ones.
Okay, so we can just measure, but we can also intervene. There, I agree with some mystical interpretation, or the Copenhagen interpretation. We can change time. We can change space. This is not me, this is Einstein. We can change the wave function by capturing the collapse, by capturing a part of the wave function. The minute I take the collapse state out of the wave function is dead. It's no longer. This is the essence of the collapse. The collapse is there all the time. The collapse state is there all the time. It's like you have a head, yeah? You have a head. If I cut off your head, the rest of your body is useless. If I cut off the collapse state and take it and put it on my photographic plate, I destroyed the rest of the wave function. Exactly like decapitating. I decapitate the wave function. So I do have the power to change the universe by measuring. But not the way we think. Not that I create the particle.
You don't create.
I don't create, I detect, but the act of detection, the act of measurement, the act of observation does change the world by destroying the wave function.
Can we say that the particles have consciousness also?
Consciousness is a different conversation, and we can have it, of course. But at this stage we are talking about things that do not require consciousness, acts and things that do not require consciousness or mind or sentience. Because as I said, this can be done by a device. Photographic plate, particle detector, and so on. Clocks in Einstein's work. There are no human beings except twice. He has clocks. So there actually is no difference between me and Copenhagen interpretation, my work and Copenhagen interpretation. We all agree that human beings have agency. They're able to shape reality. We all agree about this. But not only human beings, also stars, also planets. Everything in creation is a participant.
We don't have a chance to choose. We just see the collapsed one. Because in other understandings, your mind chooses one state and that state collapses, then it is your reality.
This is complete New Age nonsense. It has nothing to do with physics. The mind has no place in physics, is not mentioned in physics. No one ever said that. Not one physicist ever said that. This is not coming from physics. This is coming from outside physics.
Does reality have a mind, or our mind lives in reality?
So now we can transition to talk about consciousness and mind if you wish, but it's very important to clarify. There hasn't been a single, not one physicist ever who said that the observer has a mind or has consciousness. Never. Period. Not even the Copenhagen interpretation says this. Copenhagen interpretation says that the observation, the act of measurement, creates the particle. But they don't say that the observer has to be conscious or has a mind. Or it could be a clock, it could be a photographic plate.
We can live in a multi-universe, for example, but we can just see the one that our machine chooses.
I think so. That's my solution. I think we could solve all these problems by saying...
So there can be other entities in the other multiverses?
For sure there are. That's what I'm trying to say. I'm trying to say that we're limited. We must be humble. We must be modest. We're limited. Even the devices that we build, ultimately, we have to interpret the results. So when we build a special device, a detector, a photographic plate, we built it according to the limitations of the human mind, of the human brain. Ultimately, it's all limited. If there were another creature, another life form, and that life form would have totally different biology, totally different brain, they would come up with totally different measurement devices, and they maybe would be able to detect only non-collapse states and never ever detect a collapse state. I can definitely write a theory right now on this table to show that this is completely possible, to detect only non-collapse states. So, but on the other hand, we do create the universe. That part is true. We do participate, not create, but we do participate. We are co-creators because we can affect time, we can affect space, and we can definitely detect collapse states, and when we detect them, we don't create the collapse state, but the minute we detect the collapse state, we change the wave function. That part is true, no debate about this. The minute you detect the collapse, you register it, the rest of the collapse of the wave function is dead. And I give the example of decapitation. If you cut off your head, the rest of you is dead. The head is the collapse state. So we do have impact. I'm not saying we don't have impact. Mind and consciousness are...
Before this, I will ask you a strange question again while you are talking.
as opposed to all the others. Yeah.
Yes. You told that we can just see the collapse state, and it's like a colorblind state. We can just see the trees or the cars, we can just see them. Then can there be something that we cannot see in this state
for sure.
Also?
Not can, but 1,000,000% for sure.
There can be other things, other colors or other sounds that we cannot see here.
We are a selective filter, selective membrane. For sure there are things that we cannot see. Actually, the vast majority of, we cannot see the vast majority of things. Like 99.99999% of the universe is totally inaccessible to us. And we have no way in principle to discover it.
Yeah.
In principle, not a question of inventing a new device, a new machine, no. Our biology ultimately limits us, and we have to accept this limitation. We are great at exploring our slice of the universe, our frequency. We are good at exploring it, but the rest of the universe is, in principle, never accessible to us. In principle.
Yeah.
We cannot, I think, even imagine it, because we
can't imagine that we don't know.
Yes, we cannot imagine because we are forced ultimately to use our brain.
Yeah.
Even when we create artificial intelligence and so on, it's an extension. Ultimately it comes down to the brain. And whatever we think about the brain, it's a wonderful machine. It's a complex machine. It's an amazing thing. It's super evolution. I mean, no question. Still, it is a machine, and it is limited. End of story. You cannot decipher a potentially unlimited, infinite being or existence using a limited machine.
That's right.
It cannot be done. Our limitations simply show us a part of reality, and that's the end of that. That's why I think all these discussions of God or such creatures is ridiculous, because if we do accept that there is a God, and if we assume that this God is infinite and all-powerful and all-knowing, especially, has access to the past, present, and future simultaneously, and so on and so forth, there is no way on earth we can say anything meaningful about God. Because we are limited creatures, we are finite creatures. Our brains you cannot make a true statement, you cannot have a statement with a truth value. You cannot make a true statement as a limited being, you cannot make a true statement about an unlimited being. An unlimited being is not like a million times you. It's not like a multiplication of you. Because never mind how many times I multiply myself. Imagine I invent a machine and I create 1 billion some Vaknins, which is a serious nightmare. 1 billion some Vaknins, I would still not be God.
Then we are choosing the collapse state every minute, every moment, so we continue our reality with this.
Again, one thing...
Are the possible future realities also are in the space-time, waiting
Yes.
us for
In a minute,
collapse?
this is the multiverse. In a minute, we'll discuss it. But before we go there, what people don't understand is that quantum mechanics is not is a theory not about only about small particles. Even physicists are making this mistake. Quantum mechanics is a theory about reality. This is quantum mechanics. There is no reason not to use quantum mechanics to describe this mug. I can do it even here, right now. I can write a series of equations to describe this mug, all of them from quantum mechanics. This is this is a combination of trillions or billions, I don't know how many, collapse states. I'm holding in my hand right now a collapse state. And so people think that it's only about particles. No. Quantum mechanics is a competition for relativity. It's another theory of reality. All reality, including macroscopic objects. You are the outcome of numerous trillions of collapse states. And as you are sitting here right now, you're collapsing all the time. All the time we're in a state of collapse. And because we are creatures of collapse, we can detect only collapse.
I have other versions which haven't collapsed.
So first of all, I agree that there are huge parts of the universe that are in principle non-detectable and inaccessible and can never be described or even imagined. And in these parts of the universe, there is a possibility, I don't know what's the probability, but there is a possibility, of course, that there is another version of you, having a much more interesting interview with much better looking men. So that's one possibility. But it's not a necessity. It's possible, but it's not necessary. It also depends critically if the universe is infinite or not. Infinite in time and infinite in space. If the universe is not infinite, the likelihood of the multiverse is close to zero. The multiverse assumes that the universe is infinite. Infinite in time and infinite in space, infinite in every way. The wave function of the universe in the many worlds theory is infinite. I am not sure the universe is infinite. I'm also not sure that if we are inside the universe, whether we are communicating with other universes. And if we are not communicating with other universes, how will there be another version of you? There needs to be some kind of communication to create another version of MAİA in another universe.
Or they are waiting in the space-time possibilities which haven't collapsed.
So potentials are always there, but communication is a critical issue. It's a critical issue in physics. There is, of course, a limitation of the speed of light, which I believe is ultimately wrong. I don't think it's. I think it's an artifact. It's some kind of limitation in the theory of relativity, which I think in due time we will discover that speed is not limited. Definitely, speed of light is not the maximum possible. But right now, as we understand right now physics, communication is a serious problem, because to have a potential of you elsewhere in the universe or multiverse, or to have you, a copy of you elsewhere, and so on, we need to communicate this information. Somehow this information needs to be transmitted. Otherwise, how will we create exactly you, or even the potential to be you? We need to communicate this.
Do we need to communicate with the possibilities?
You need to communicate, everything you need to communicate. You need to communicate. I mean, potential in principle doesn't need to be communicated, but the potential for MAİA needs to be communicated, because MAİA is highly specific. The potential generally is, for any event, is there, but the potential for a specific event needs to be communicated. So, how will we communicate this potential? There is a massive problem about communication. In quantum mechanics, we have the issue of entanglement. Entanglement is when we have two particles, they form a single system, and then we break the system. One particle remains here, and one particle is in Turkey. And now, according to quantum mechanics, if I change the particle here, spin it in a different way, for example, the other particle in Turkey instantaneously will change as well, because they used to be part of the same system.
Yes.
But how did the particle in Turkey know that I changed the particle here? How did this information go there?
But we observe the particles in the collapse state. We don't know how they act in the possibility state.
These are two particles that do exist. Real
Yes, but
particles.
in the collapse state, they exist.
So we have two particles. They're real. We measure them. We capture them. We can, they're real. And then if I change the particle here, right now,
And Izmir changes.
yes.
Okay.
How? I change the particle here. That second, split second, the particle there changed. There was no difference in time. They changed at the same time. How did the particle there know to change? Who informed the particle there? Who told the particle? How did the information go there? So the problem of communication in modern physics is a massive problem, very big problem. And entanglement is a major challenge to the assumption of the limitation of the speed of light. Because it seems as if the information was transferred from this particle here to the particle in Turkey at an infinite speed. Infinite speed. Simultaneity. And this challenges the limitation of speed of light, and by implication challenges special relativity completely. So we have not resolved the issue of communication. It's one of the big remaining issues. In my chronon field theory, the issue is resolved. My chronon field theory resolves, to the best of my knowledge, most of the problems that exist today in physics, to the best of my knowledge. And one of the problems that is solved is the communication problem, because in my chronon field theory, there is a field of time, and this time is a series of potentialities. And so, in my chronon field theory, particles are not objects; they are events. In a field of time, the field of time cannot create matter. It can create only events. Because in time you have events. You don't have microphones in time, you have events. Some of these events have characteristics that we call matter. Other events have characteristics that we call motion. So the whole language of physics emerges from this. And if this is the case, then what we perceive as distance, velocity, and so on and so forth, are not needed anymore. Most of the language is not needed anymore. And we could definitely have simultaneous events without breaking any limit. But that's very complicated to explain. I don't think it's for a podcast. But so, as you see, there are many problems with many of these assumptions. And also the definition of universe is very problematic.
Now we understand time in a very different perspective. Now I'm a collapsed existence, and I'm collapsing every moment, every second, and it's my life. This collapses is time for me. My mind creates the time.
Yes, time eventuates. Time becomes an event. And when we put many such events together, it's MAİA. So you are constantly being, in my work, you're constantly being regenerated. Constantly, events are happening. Trillions of events are happening. And all these trillions of events together are MAİA. The collapse, you're in a constant collapse state because your body changes all the time. For example, many skin cells are falling, you're changing your skin. We're changing about 90% of the body every 5 years. 90% of the cells of the body change every 5 years. So all these require collapse states. You need elementary particles to put them into atoms. Atoms put together molecules. Molecules become your skin. So you need to constantly collapse in order to remain alive. But this raises a very interesting thing, because if you are the collapsed state, then you start off as a wave function.
Yes.
That means all the time there are around you trillions of wave functions, trillions of wave functions, and these wave functions collapse into MAİA. These wave functions, this field of wave functions that collapses into MAİA, that is the chronon field, that is a time field.
So I can observe myself, collapsed self. Is it fate? Because I can just see the collapsed one.
Yeah, it's not like you're creating tradition, it's not like you're creating real time, but you're creating traditional perception
Yes.
of time, like change. Time, our perception of time is change. How do we measure time? We measure time by changing the position of the...
Yes.
So, change is time. In our minds, change is time. And yes, you're changing all the time, because there are trillions of wave functions that collapse into you. You are sensing this change. You are feeling this change. And you interpret it in your mind as time.
Time, yes.
As time. But the real time is a field.
There is no time.
And,
normally.
and there's no time in the way we think.
Yes.
There's no time. Time is omnipresent. Time is a given, a field. That is not some Vaknin. That is Albert Einstein. Albert Einstein said that time, there's no past, there's no present, there's no future.
Yeah.
This is illusion. All exists, and I
Fourth
agree.
dimension.
In my chronon field theory, there is a field of time. Everything exists simultaneously, but exists not really, but there's potential. Everything has the potential to exist, and then some of these potentials
Collapse.
eventuate. They become events, and a sufficient number of events becomes MAÍA. So you become out of the time field all the time. You're generated out of the time field. You emerge from the time field like some sculpture. You emerge all the time, and then you disintegrate into the time field, and you become again. It's a beautiful imagery. It's
Yes,
a beautiful metaphor, you know. And it also means that you're fully integrated with the universe. Fully integrated with the universe. And it is true that your actions have consequences on the universe. It's true. The minute you collapse, the minute because you are the result of collapse, the minute you collapse, the wave functions around you are destroyed. They're decapitated, they're destroyed. So you are destroying all the time wave functions. You're destroying trillions of wave functions all the time. When you eventuate from the field of time, when you emerge from the field of time, it's not only an act of creation, the collapse, but it's an act of destruction as well. You destroyed many potentials. You could have been MAÍA 2 or MAÍA 6, but you became MAÍA 1. To become MAÍA 1, you needed to destroy MAÍA 3 and MAÍA 6 and MAÍA 9. You needed to destroy them.
But I can't choose them.
You don't choose. There's no choice here.
There is
But
no
you
choice.
do have an
I
impact.
have to be that.
Yes, but you do have an impact. It's not a choice, but you have an impact.
How?
By collapsing. The fact that you're collapsing eliminates all other options, eliminates the potentials. Similarly, if you as MAÍA, as a macroscopic object, you would move at the speed of light, you would affect time. You would create a variation of time, a local time, your local time, which would be different to the local time, to other times in the universe. So you will have your own time. It's like time is a field of potentials, or in relativity theory, there is time, but you shape it. You choose your own time. It's like you have a piece of fabric, okay, you have a piece of fabric, but you decide to make this shirt. This shirt is only your shirt. It reflects your creativity, your imagination, so this is only your shirt. You can choose only your time by moving fast. Actually, you don't have to move at the speed of light. We are beginning to have relativistic effects when we drive a car. When you drive a car, your time slows down. It slows down imperceptibly. You don't perceive it. Again, because your equipment is not sensitive enough. Your brain is not sensitive enough to detect the difference in time when you drive a car. But it is a fact that when you drive a car, the time, your local time, slows down. You gain some time because it's slower. If I walk and you drive a car, you are aging less than me. I'm aging a lot more than you. So even by driving a car, you're shaping time. You're creating an island of time, which is all yours. This is the impact we have on the world, and this is the responsibility we have.
My observation to the collapse state has an effect to the other collapse state, which will come later, because it's always collapsing. I'm observing the collapsing state and then again observing a collapsing state. Do I have an effect on a collapsing state?
In some ways. So if you kill me, for example, which I would fully understand, then
but it's then it's
of
a
course,
collapse state.
Of course, you would have an effect on the future of my collapses. You know, and you would transition me from one type of collapse to another, as a corpse. So, yes, human volition, human choices, human decisions, and so on, can move us, allow us to move between collapses. So we live in a collapse space. We live in a space of collapses, only collapses, not the wave function, but only collapses. So of course we can influence this space. And this is again the core of the chronon field theory. They are potentials. It's all potential. If you make a choice, you eventuate one of these potentials. You convert potential to event. If you choose to shoot me,
then I have an effect.
Of course.
Okay.
You have an effect not only when you have a will or intention or when you act. You have an effect by existing. When you exist, you are in a collapse state. And so you affect wave functions.
And I change the wave
You change the world. Oh, absolutely. When I talk to people and they are suicidal, I tell them, listen, one thing you need to know. Your life determines the universe. If the universe will never be the same without you, because the wave function describes, in the first part of the wave function, we describe the totality of the universe from the beginning of time. And when we solve the wave function, when we collapse it or reduce it, we are actually solving the equation of the universe. And the universe, the minute we detected elementary, the universe will never be the same. Never. All the universe will never be the same. Not our small corner.
It's like a butterfly effect.
Much bigger even. Because the butterfly effect would create a...
It's like a wave function and affects...
It's like a butterfly that affects all the universe.
Yes.
There is no possibility to detect a collapse state or to be in a collapse state. There's no possibility without changing the whole universe simultaneously. And I mean it. This is not mystics. All universe changes. So your life is super crucial. If you were to kill yourself tomorrow, the whole universe would change. By the way, dramatically, because you represent trillions of collapses, not one collapse. I change the whole universe by detecting one elementary particle. If I put a photographic plate here and it detects one elementary particle, the whole universe changes. Because I destroyed the wave function. That is one particle. You have trillions and quadrillions of particles, all of them collapsing all the time. All of them, you have a massive influence on the universe. Massive influence on the universe. You know? If you were to disappear tomorrow, the universe would never be the same in a fundamental way, not in a minor way, you know. And that is, and you know, I'm not a mystic, I'm a scientist. Everything I'm saying is science. Nothing to do with mysticism. So, and people don't understand it, and so they say we're going to commit suicide. And they don't understand. They are an integral part of the fabric of the entire universe. And so there's a question, open question of moral responsibility. Do you have a moral responsibility, not even to other people, but to the whole universe? Would you dare? Would you dare to interfere with the whole universe, with the order and structure of the whole universe by killing yourself? This is what I'm saying to people who want to commit suicide.
And I was going to ask you, Is the observer an integral part of the observation itself? And you gave the answer now.
But you wanted to ask me about mind and consciousness? I don't
Yes,
remember. Yeah.
I'm going to ask you, is reality have a mind, or reality is in our mind?
Mind and consciousness are very, very, very problematic concepts. Very. And the reason they're very problematic is that there is no way for us to obtain a second opinion. In science, generally, we create theories and hypotheses, and we create predictions, and we falsify the predictions, and so on. All the scientific activity is based on the convention or the assumption that the observer has little impact on the observed. So there is observer and observed. This is Descartes. This is the Cartesian system of observer and observed. In the 20th century advances in physics began to challenge this. They began to merge the observer with the observed. So you could no longer say, I'm observing, but I have no impact. I am objective. I'm not impacting what I'm observing. You could observe macroscopic objects. You can observe glasses. You can observe the sun. And then your impact would be minimal, so minimal that you can ignore it. But you cannot observe elementary particles that way, because just by observing them, you're changing them. So it became a problem, the distinction between observer and observed. And the situation is much worse when we are discussing the mind or consciousness. Because when we discuss this, we have no observer. If I'm trying to understand the concept of mind and consciousness, I have to use my mind and consciousness. And this is very bad science.
Yeah.
Extremely bad science.
There is no observer again.
I don't have an alien. I don't have an alien who can observe me and say, okay, I come from a planet where we don't have mind and we don't have consciousness, and I can observe you, and this is a phenomenon unique to you. Or, in my planet, also we have mind and consciousness, so probably it has to do something with intelligence. I don't have this. I don't have input from anything that doesn't have a mind and consciousness. Everything you see, this camera, everything has a mind and consciousness. What do I mean? When we create devices, we put our mind and consciousness into the device.
Inside it.
Our devices are built in a way that they maximally and optimally interact with our mind and consciousness. So they are extensions of our mind and consciousness. This laptop is an extension of your brain. This camera is an extension of my eye, which is a critical part of my mind and consciousness. So I am in an environment where mind and consciousness are everywhere. I cannot exit this environment. I cannot step outside the environment and watch it, observe it, analyze it. I cannot do this. Even if I want to analyze mind and consciousness, I have to use mind and consciousness. That's a major limitation. It's a major problem. The second thing is, mind is an experience. The mind is an experience. It crucially depends on experiencing it. It's not an objective thing, which whether you experience or not is there. If you stop experiencing your mind, you don't have a mind. So it's outcome of experience. And then the question is, because we experience everything with our bodies, we're experiencing cold and hot and everything through the body. Our brain is part of the body. We cannot divorce the brain. Say, body is body, brain is brain. No, the brain is part of the body. So every experience is somatic. Every experience is body-based. And then it raises the question, since mind crucially depends on experience, there's no mind without experience, maybe the mind is a bodily artifact. Maybe this distinction we make between mind and body is idiotic, because take away the body, there will never be a mind. And then people say, no, it's not true. We can build a computer, and that computer will have a mind. That computer also has a body. There's no software without hardware. There's no mind without hardware. There's no mind without body. And so it's very safe to say that the mind is an artifact, a manifestation, an outcome, byproduct, side effect of having a body. And all these distinctions between mind and body are completely counterfactual, ridiculous. And so why do we make these distinctions? Because we want to feel special. Why do we want to feel special? Because we do feel special. Our experience of ourselves appears to be special, privileged, unique somehow. Introspection gives us the illusion that there's nobody like us. Like if I experience some Vaknin, and I'm pretty convinced that there's nobody else like some Vaknin, luckily for humanity. So one could say, therefore, that the experience of mind and consciousness has to do with idiosyncrasy, has to do with the belief that you are unique somehow. And the belief that you are unique somehow depends on your self-observation, on your introspection through your mind. And so it's what we call in philosophy tautology. Tautology. It goes like this. I have a mind. I have a mind. How do I know I have a mind? Because I observe myself. And having observed myself, I realize that I'm unique. I have a part of myself that is accessible only to me. Only I can access it. No one else can access. I have privileged access. Oh. So I have a mind. How do I know I have a mind? Because I have a privileged access to a specific area, inaccessible to all other human beings or the whole universe, accessible only to me. That makes me special, or unique, or idiosyncratic. And it also means that the combination called Vaknin and the specialty, the uniqueness of Vaknin also mean that Vaknin has a mind. In other words, I know that I have a mind because I use my mind to observe myself. Of course, this is
you
what
can
we call,
experience yourself with your mind.
But I know that I have a mind because I use my mind is a very stupid sentence. It's what we call in philosophy tautology. It's a sentence that says nothing. I know that I have a mind because I use my mind to observe it. This sentence doesn't add any new information, leads you to nowhere, doesn't provide insight, cannot generate hypotheses. It's a meaningless sentence. I have a mind because I observe that I have a mind. Yes, but you use the mind to observe the mind. I'm asking you, what is the mind? And you're telling me the mind is what I observe with my mind. What kind of answer is this?
What is mind then?
So, what kind of answer is this? And what I'm saying is even more severe. I cannot give you any other answer. There is no other answer. The only answer I can give you is I know that I have a mind because I use my mind to observe it. I use my mind to observe my mind, so I know I have a mind. This sentence is empty. It's meaningless because it does not answer the question, what is a mind? However, there's no other sentence, no other answer I can give you. Because whatever answer I give you, I have to give you by using my mind.
Yeah.
It's a tautology. The situation is even much worse with consciousness. Because while with the mind I can say I use my mind to observe my mind, whatever that means, with consciousness I cannot even use this sentence. I cannot, for example, say I use my consciousness to observe my consciousness. Or I'm conscious that I'm conscious. I cannot say even that. If I say I am conscious that I'm conscious, that raises the question, how do I know that I'm conscious? Because the condition is I am conscious because I'm conscious. But how do you know that you're conscious? Because I'm conscious.
Awareness. Maybe it's awareness of knowing consciousness.
How do you know that you are aware? Because I'm aware of it.
Yes.
As you see, these are circular sentences. They lead nowhere. They teach you nothing.
Where is the consciousness? In the brain, in the mind.
What I'm trying to say is that you cannot say anything meaningful about the mind and consciousness. Definitely not scientific, but even philosophically. There is no sentence about the mind and consciousness that has any meaning, because you are forced to use mind and consciousness to make any statements about mind and consciousness. How do you know you're conscious? I'm conscious that I'm conscious, yes, but how do you know you're conscious? Because I'm conscious. How do you know you have a mind? I observed it. What did you use to observe your mind? My mind.
My mind.
It's meaningless, stupid.
It's like, it's
So
strange.
this is the kind of sentences that we call in philosophy undecidables. Undecidables are sentences where you cannot create an outside argument that uses elements from outside the topic discussed. If you ask me, for example, what is this? What is this? I can use words, statements, concepts that are not connected to the mug to describe the mug. And it will give you a lot of information. For example, I can tell you, this is something where I can put water. Water is not an integral part of the mug. The mug remains mug without water. But now you understand that it can contain water, and by implications other liquids. So you learn a lot about the mug because I can use concepts outside the mug, not connected to the mug. But imagine that this is not a mug, it's my mind. I cannot use any concept that is not connected to the mind. In other words, any conversation about mind and consciousness is totally meaningless and teaches us nothing and can lead nowhere. And we call it undecidables. Another example of undecidable proposition is God. God is an undecidable proposition. When I ask you, how do you know that there is God? You can say, for example, well, I look at creation. Creation is amazing. Could not have been random. Must be designed by someone, and so on and so forth. I say, okay. And who designed creation? God. So how do you know that God exists? There is creation. And who designed the creation? God.
It's like
The only way to refer to God is by using God. The only way to refer to the mind is by using the mind. The only way to refer to consciousness is by using consciousness. These are circular tautological propositions that teach us nothing about the world. They're self-referential, they're auto-reflective, they're self-reflective. And these kind of systems are considered, in science at least, meaningless. That's why I'm very hesitant to use words like this. However, we can say, absolutely, that there is an inner experience that people report, they report to us, something which is an inner experience. And that this inner experience is perceived by people to have a privileged position, to be special. And they keep reporting it. And everyone is reporting it, even I. We're all reporting this inner experience, and we need to study it somehow. This inner experience, we cannot use the mind to study it, because this is the mind. This inner experience is the mind, and we cannot use the mind to study the mind. Again, it's a circular,
the same circle.
but we can use the body. The body is not the mind. The body is like water. I ask you, what is a mug? I can put water here. When I ask you, what is the mind? If I use the mind to explain the mind, it's nonsense. But I can use the body to explain the mind. The body has nothing, is not the mind. They exist in the same framework, but we believe, we feel it's not the mind. So the only way to talk meaningfully about the mind is to explore the body. The only way. If you try to explain the mind using the mind, you get nowhere. You need to explain the mind using something that is not the mind, and that is the body. That's why most philosophers nowadays are trying to come up with explanations of the mind that are based on the brain.
Yeah.
The brain is part of the body. We use the body to try to understand the mind, or consciousness, or whatever it is. That raises another issue, as always. It never ends.
Does the cognition and perception affect the observation of the reality?
Yes, of course. Not only observation of reality, but
Life.
there was a philosopher, his name was Feyerabend. Feyerabend said that as science changes, as there are new theories, we explain the same experiments completely differently.
The same experiment.
Same experiment,
Yeah.
completely differently. He said science is not about the truth. Science is not about facts. Science is a system where we refer to other science. So scientific theories refer to scientific theories, not to reality. He said science is an internal conversation. It has nothing to do with reality. As the internal conversation changes, the same experiments, the same get a totally different interpretation that is contradictory to the previous interpretation. And there was a guy called Kuhn, K-U-H-N, Thomas Kuhn, and he came up with the idea of paradigm shift in science, where when the paradigm changes, everything we know as fact acquires a totally new interpretation. And we see it in a completely different way. So even science is affected by changing fashions, by prejudices, by narratives. This is science, where we are very strong and rigorous. And imagine a layman, someone who is not a scientist, says, of course, the impact of perception, on cognition, and on interpreting the observation, not on observation, but on interpretations of observations. Of course, it's a massive impact. If your perception is not an objective thing, your cognition, and even more so your emotions, dictate what you observe. They tell you what to observe. And then based on what you observe, you perceive. Perception is outcome of observation, but observation is never random, never objective, but always highly biased, highly prejudiced, highly dictated, highly narrow observation. If we believe in something, we are very likely to observe only some things and not observe other things. Someone who is religious is likely to observe only some things and refuse to observe other things. Deny them, delete them, oppose them. He will never observe them. Someone who is a scientist and believes that speed of light is the greatest speed in the universe is likely to observe only things that will support this view, and is likely to deny and fight and conflict and delete and every proof, every evidence, every observation that undermines this belief, this taboo of speed of light is the greatest speed. So there is inbuilt bias. And we have two types of biases. We're discussing this. One is called doxastic bias. Doxastic bias is our beliefs dictate what we are likely to observe, and our observations then dictate the kind of theories we're going to generate about reality. So our theories of reality emanate from our beliefs. Our beliefs are the preconditions for our theories of reality. And in a way, that means that our beliefs are the only reality. Because then the rest is falsification. We falsify reality to fit the belief. Beliefs are the only reality, it seems. This is the doxastic approach. The axiological approach says that we have values, and then values, beliefs, religions, ideologies, so on, these narratives, they dictate what we choose to observe, and then because our observations are narrow and limited and biased, then they dictate the theories that we create, and the theories that we create motivate our behaviors. In both approaches, the belief is that there is no objective reality, but that our perception of objectivity is very subjective and very dependent, crucially dependent, on prior mental artifacts, such as values, such as beliefs. But of course, delusions, emotions, mental illness, trauma, these are all filters. They filter out reality. Human beings are busy 99.99% of the time falsifying reality. That's the main activity of human beings. The main. Freud knew it, of course, and Freud and his daughter, Anna Freud, they came up with the idea of psychological defense mechanisms. Psychological defense mechanisms are mechanisms, psychological dynamics, whose main task is to falsify reality. Deny, repress, delete, reframe, everything, just not confront reality as it is.
Why do we do this, for example?
Because reality is
Hurtful?
intolerable, hurtful, unbearable, threatening, hostile, perceived as hostile. Reality is impersonal. Reality doesn't care about you if you die or leave. And to realize that the world doesn't care about you, that you can die, you can live, you can be happy, you can be sad. No, I mean, the world doesn't care. The galaxies don't care. The sun doesn't care. And that's why we invented imaginary friends, like God, because we are very alone. It is this sense of existential loneliness that is very threatening. So we need to populate our space with imaginary friends, and actually all friends are imaginary, even when they're not imaginary. Even your family is imaginary. It's all these are. What is a family? What is a nation? What is a? These are abstracts. These are total inventions.
To feel insecurity, maybe.
To feel less lonely. As Sartre observed, the key issue is loneliness. So you are alone. You're truly so, and you die alone, of course, but you actually live alone. And this is a realization people cannot take. So they invent imaginary friends like God. They invent abstract frameworks where they don't feel alone, like a family or nation state or whatever. At least in the family, there is a sharing of biological material. But no one can explain to me why the fact that I share biological material with someone should make me feel less lonely. I don't see the connection here. The fact that we convince ourselves that sharing biological material makes us less lonely and less sad is fiction. It's fiction. The fact that I have a son and I share with my son 50% of my DNA, why should this make me less lonely? I have no idea. Why should this make me less sad? I have no idea. Why the sharing of biological material should make me more happy? I have no idea. I don't see any connection. It's fiction. It's a delusion. We're lying to ourselves. We're deceiving ourselves. We're telling ourselves narratives and stories.
Is life traumatic to the human beings?
Life, the main engine of growth and personal development is losses. The main. We learn nothing from success. We learn absolutely nothing from happiness. These conditions are not conducive to growth and development. They're conducive to stasis. They're conducive to freezing. They're conducive to... So they're not good. In the long view, happiness is the worst thing that can happen to you because you have no incentive to change. You have no incentive to learn. The more happy you are. And there was a famous book by Wells, H.G. Wells, in the 19th century, about a future world where everyone is happy because all their needs are met and they don't have to work and all day they sleep in the sun and play and and so on. And he shows how this kind of happiness, absolute, complete happiness, leads to degeneration, leads to a destruction, self-destruction. The worst thing can happen to you is when nothing bad happens to you. You need losses, you need grief, you need pain. These are main drivers.
We run away from the pain.
It's a form of growing up. When you run away from pain, you're growing up. When you try to avoid pain, it's a process of learning. You learn how to avoid pain. Losses teach you about the importance of things. When you lose someone, or when you lose some position, or you learn how much it meant to you, and it prepares you for the next time. So these are drivers of growth and development. And trauma is a different thing. Whereas losses and so on and so forth are constructive, trauma is destructive. I compare trauma to happiness. In both these conditions, are degenerative. They're not good for you. They stunt your growth. They arrest your development. They are conditions in which you never change, you never transform, and that makes you less ready for life. The life requires you to be prepared for all eventualities and to be very flexible and agile and to be adaptive and so on. When you're happy, you don't have any incentive to change or to be adaptive.
Yeah.
When you are traumatized, the same. You don't have incentive to change or to be adaptive. You withdraw, you avoid, you constrict, so you're very defensive and so on. People confuse trauma and crisis. Crisis is a good thing. Crisis creates growth. Trauma doesn't. Trauma freezes you.
Then we will continue in the next episode with mental health from this part. Thank you very much. See you in the next episode.
Thank you for having me.
Thank you.
Thank you for surviving this.